Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topics in the concrete. See, concrete is the main pillar or the backbone for any structure. So any project we even cannot think without the concrete. So there is a very much important to do the mix design or to find out the right proportion for the right grade of concrete. Today I will discuss about the high strength concrete mix design, how to do as per IS 10262. So stay tuned until the end to get the full information, and if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video you will get immediate notification. So without wasting time, let's jump into the subject, that is high strength concrete mix design as per IS 10262. With the subject, that is a high strength concrete mix design. Now, what is high strength? As per IS 10262, it has given the guidelines that any concrete which has a strength greater than 65 is called the high strength concrete. So what does it mean? It does mean that 28 days concrete cube strength must be 65 or more, then that concrete will be considered as a high strength concrete. So nowadays we are doing multi skyscraper buildings, dams, bridges and everything, and on that places we need high strength concretes. The present in scenario, that is we need a high strength concrete. So that is why we need to know how to design the high strength concrete. So here we are considering the high strength is M70. And what is the type of cement we are using? That is OPC 53 conforming to IS 269, and silica fume and considering the IS 15388. Also we will use the fly ash and as per 3812. So grade of concrete is M70, type of cement is OPC 53, silica fume is conforming to IS 15388, and maximum nominal size of aggregates 20 mm, because it is very much important to know what is the maximum size of aggregates that we can use in any concrete, because depending upon the maximum size of the aggregate, water absorptions, strength capacity, that water requirement, that all become different. So that is why it is important to know what is the maximum nominal size of aggregate. Now for say for example, here we are using the maximum size of aggregate is 20 mm, and we can start with the 10 mm, 12 mm, whatever. The code has given that provision also, but for the sake of the mix design, we are considering here that it is a 20 mm aggregate. Now, what is the exposure condition that we need to understand first? Now, what is the exposure condition? Exposure condition is that where the concrete is being placed. Now, maybe there is a desert area, maybe there may be the rainy area or the snow area, or there is a repeated tidal wave is there. So what you need to know, you need to know what is the exposure condition as per IS 456 in table 3 and table 5. And what is different types of exposure condition, I have made a detailed video on that. The environmental exposure conditions as per IS 456, please check, link is there or in the description. You will get the full information about the exposure condition of the concrete. So depending upon the area or depending upon the uses or depending upon the project requirement, we need to find out first what will be my exposure condition as per the guidelines. So let's see in the table 3 in IS 456, here it is. In table 3 there is a 5 categories is there in the mild, moderate, severe, very severe and extreme. Mild category, concrete surface protected against weather. So mild is very much that is not protected, and the moderate is concrete surface sheltered from severe rain. Severe, very severe and extreme. So in our cases we need to find out which area. Suppose depending upon the exposure condition, here is in the table 5, you can see in the table 5 of IS 456, here is the exposure condition, and it is the what is saying minimum cement content, maximum water cement ratio and minimum grade of concrete for different exposure condition, and nominal aggregate 20 mm, nominal maximum size. So whenever I consider what is my exposure condition, then I can take from this table, that is from the table 5, what will be my condition. See, say for example, where we are taking that severe condition. In the severe condition, 4-5, if it is a grade is M40, M25, here you can say 0.4, and M40 is 0.4, and the minimum cement concrete is 360. So that is why these two table is very much important, this table 3 and the table 5 of IS 456, because it will the fundamental things to start design as per the guidelines. So here we are saying the 320 kg is minimum and maximum water cement ratio is 0.45. We have already considered as per the exposure condition, and what is the maximum cement content, and what is the minimum cement content, and what is the maximum water cement ratio, because we need to satisfy this criteria whenever we are doing the mixed design. The next is we need to know what is the workability, because if depending upon the workability also, our moisture or the water percentage will be varied. We will see in the later that according to the slum criteria, we need to change the moisture requirement or the water requirement. From where we can get that one slump and workability criteria, that is in clause 7.1 of IS 456. There is a table is given. So here we are considering 120 mm for the slump, and method of concrete placing we are considering it's a pumping, because there are other type also, direct pouring, shoot or the pumping or the manual, whatever. So why it is important, because depending also that we need to check our criteria, and then we need to do the mixed design. Then degree of site control, good, because if depending upon that, I will come later that how the target mean strength is become the changes. So type of aggregate, that is also we need to know very much well, that is we are considering here crushed angular aggregate. There are other aggregate also, but the mixed design criteria or the concrete criteria, it is the best to use the crushed angular type of concrete. So these are all the assumption or we need to make the according to the requirement. And now maximum cement content. So minimum cement content already we have got from the table 3 and table 5 of IS 456, and from the maximum water cement also we can find out from the clause 8.2.42 of IS 456. Here is saying 450 kg is the maximum water cement content can be in the mixed design. So what we are can understand, that is the minimum cement content is 320 and the maximum content is 450. So we need to play in between 320 to 450. Where we are getting that one, the minimum content we are getting from the table 3 and the table 5 of IS 456, and the maximum we are getting from the clause 8.2.42 of IS 456. Now what we have already considered everything, what is the grade, what is the maximum size of aggregate, what is the maximum water cement content, maximum minimum cement content, what is the condition of the exposure condition. Now the next part is the chemical admixture type. Why? Because without the admixture it is not possible to do the mixed design or do the concrete. So that is why we need to use the chemical admixture. Now what is chemical admixture, what are the different types of chemical admixtures? I have made already a detailed video on that. Link is there or in the description, please check. You will get the full information about the different types of admixture used in the construction as per IS 9103 in India. So why it is important, because you need to know what is my criteria. So here we are using the super plasticizer, that is polycarboxylate ether based, that in short it is called PCE admixture. It is a super plasticizer. It is reducing drastically the water content of the mixes. And now we need to go for the mixed design criteria. Now we need to know, in order to get the what is will be the quantity and what will be the percentage, we need to know the specific gravity of each and every element we are using in the concrete. The first is cement, that is 3.15, OPC 43 conforming to IS 269, fly ash 2.2, silica fume 2.2, coarse aggregate at SSD condition 2.74, fine aggregate at SSD condition 2.65, chemical admixture is 1.08. Now here it is a condition, that SSD condition. Now what is SSD condition? The SSD consider called is the surface saturation dry condition. Now To understand this, I have also made a detailed video. Link is there or in the description. Please check, you will get the full information. To say for understanding now, the SSD condition is that the aggregate, that is coarse or the fine aggregate, it is observing the moisture. So what will the moisture percentage that we need to consider whenever we are doing the mix design, because the water content to be calculated as per the mix design criteria. So what will be the mix design that we have to do, that will be decided as per the moisture content of the coarse aggregate and the fine aggregate. Now, so SSD condition is that sometimes if the aggregate is too much dry, so whenever we add water into the mix, it will absorb the water from the mix, and sometimes it has moisture more, so what will happen, it will release the moisture into the mix. In the both the condition, our moisture content or the water content criteria will be disturbed. So and another condition is called SSD condition, that is, in this condition neither the aggregate release the water into the mix nor it will absorb the water from the mix. So we can say it is the standard condition for the mix design, but it's actual, we need to consider the moisture content, because within the SSD condition it is very much difficult to attain. So for example here, we for the mixed design criteria or the mixed design purpose, what we are saying, cement 3.5, fly ash 2.2, silica fume 2.2, coarse aggregate and SSD 2.74, 2.65 and 1.08. Now water absorption we are considering, coarse aggregate is 0.5% and fine aggregate is 1%, because until unless we are not knowing about the exact percentage of water absorption, we need to consider this as a water. Now moisture content of aggregate considering SSD condition, see here we are considering in SSD condition, that means it is nil, coarse aggregate nil, the fine aggregate nil. So it is very much to understand that in SSD condition neither or nor there is no moisture exchange from the aggregate to the mix. So it is the ultimate condition, we can make design, but if we want to do the correct method design, then for that we need to consider the moisture content and we need to find out the moisture content as per the actual. Now we need to do the sieve analysis, because we need to satisfy the criteria whatever mentioned in the IS 383. IS 380 is for the coarse and fine aggregate mixed design criteria for the coarse and fine aggregate for the mixed design. Here you can see in table 7 coarse aggregate there are different 63, 40, 20, 60 mm, 12.5, 10 mm and percentage passing or combined. See, if you are using 20 mm or 10 mm together, this table, and if you are passing in 20 or 10 mm, this criteria is missing. If you are mixing 16 or 12 mm, that is the grading aggregate, but here we are using 20. So these table has to follow. So say for example we are doing this 20 mm, 10 mm, 4.75, 20, 100 and 2.85, 100 and 70.35, 50 and 1.45. So here is a percentage different fraction, quotes 20, 10 mm, these 100%, 100%, the 50%, 50%. So here we can mix together and we can make our as per the requirement. So what in to say that we have 20 mm, we have 10 mm, we have 12.5 mm. So we can mix 20 and 10 mm, but criteria whatever we are mentioning, that maximum is aggregate size is 20 mm. So we cannot go beyond, but we can mix, and according to the mix, this table 7 has to satisfy the criteria mentioned in the table 7 of the coarse aggregate. Now for the fine aggregate, that is also in the IS 383 and it is mentioned in table 9. Now we have, there are 4 grading zone of the sand, that is zone 1, zone 2, zone 3, zone 4. You need to sieve analysis the sand whatever available in the site, and you need to find out which zone is available. For our mixed design criteria, we are considering that our grading zone is zone 2. That means in 10 mm it will pass 100%, 4.75 it is 90 to 100 and so on. This 2.356 is like that. So what are you considering, that for our criteria is zone 2 sand we are using. Why? Because this zone 2 is very much stable form and the well graded, so that whatever we are using in the mix, we can get the right kind of proportion or the well graded aggregate in the mix. Now next consider is, we need to consider after that, then what we need to do, we have to find out the water content or the water cement ratio. What is water cement ratio and what is that? That means water cement ratio is that what is the water percentage and what is the cementitious material, not only the cement, that cement and other the fly ash, silica fume, whatever, that cementitious material. But before that, we need to finalize what is our target mean strength. See, in the target mean strength, you can check in the clause 4.2 of IS 10262. It is saying that in order that not more than the specified proportion of stress stressors are likely to fall below the characteristic strength, the concrete mix has to be proportionate for higher target mean compressive strength FCK dot. That margin over characteristic strength is given by the following relation. So what the relation? FCK dot is our target mean strength, FCK plus 1.65 S. So FCK is our characteristic compression strength. Here it is M70 and 1.65 is the factor, and S is the standard deviation in Newton per millimeter square, or X is the factor based on the grade of the concrete. So in these two, whatever the maximum that we need to consider for the mix design. For that, where we can get this, it is also saying it's in the IS 10262. It's a table given, but you can find out the standard deviation based on the trial, but not less than the 30 samples. If it is less than the 30 samples, that the standard deviation will not be accepted. So what is my FCK dot 70 plus 1.65 and what is the standard deviation? Here you can say M70 standard deviation is 6. So what will be the target mean strength? That is 70 plus 1.65 into 6, that is it's become 79.9. So here is the table 2, it is given the standard deviation, but if you want to establish the standard deviation, you can, but it should not be the less than the 30 sample, because in the IS 456 and IS 10262 also given this criteria that minimum sample to establish the standard deviation is simply minimum less than 30, not less than 30. And another criteria is FCK dot is FCK plus X. And what is the X? Here from the X you can find out in the table 1 of the IS 10262, that is for MC 65 and above 8. So 70 plus 8 is become 78 Newton per millimeter square, and from this criteria 79.9 millimeter square. Now what is our IS code saying? That whichever is higher. So what will be our target mean strength? Our target mean strength will be 79.9, is not the 78 because it's less. So whatever the calculation we will make, that calculation will be as per the 79.9. Now approximate air content we need to know. Why? In the mix, whenever we are making the dry one, there should be a mix, so and there should be a air void. So what will be the air content, that we need to understand, because if we are not considering the air content, then our result will be erroneous, our design will be erroneous. So in order to get the right kind of mix, we need to find out the approximate air content. So from where we can get, in table 6 of IS 10262 for 20 mm aggregate, you can see from this table is air content is only 0.5%. So if it is a 12.5, it become 0.8, and if it is 10, it become 1. So what is my air content? That my air content is 0.15. Now we have to find out the water cement ratio, which is the backbone for any concrete mix. So that is the ratio in between what and the cementitious material. So from where we can get one? That we can get from the table 8 of IS 10262. In for the high strength concrete, it's given the criteria mentioned in the table 8 of IS 10262. See, here it is, our criteria is 79.9 and maximum aggregate size is 0.2 20 mm. So from here we can find out it is nearly 79.9. It's been really equal to 80. So our mixed design criteria or the water cement ratio will become 0.29. So here it is very much important to know the water cement ratio. But what is water cement ratio and what is the factor effective water cement ratio and how to determine the optimal water cement ratio, I have made a detailed video, and if you want to know, please check in the description, you will get the full information. So what is the maximum water cement ratio? From table 5 we can find that is 0.45. Hence it is okay. Why? Because our design criteria or design mix water cement ratio is 0.29, but IS 456 has given the guidelines, we cannot go beyond 0.45. So this criteria has satisfied the IS 456. Now what do you have to find out? Now water cement ratio we have already find out, that is 0.29, and the maximum water content, water cement ratio, and the characteristic strength, that is on what percentage or what compressive strength we need to do the design, that also we already find out from table 7 and clause 6.2.4 for 20 mm aggregate, and we are getting this 202 kg of water is required for 1 cubic meter of the concrete. But we are using the water reducing super plasticizer PCE type. Why? Because this 202 kg is the more water, and it's bleeding, and the strength will not be as per the requirement. So that is why we need to reduce the water content. How we can reduce the water content? Using the super plasticizer, that is PCE based. So what will be the doses will be 0.5%, and reducing will be 30% of water. So from where we can find out the dose? In clause G3 of IS 10262. See, here it is 1.2, 0.5 to 1.5%, and water reduction is 15 to 30%. See, it is for the trial only, we can use this 0.5%, but if it is rigged, we can increase that one also, because code has given the permission to use up to 1.5%. So what will be our reducing water content? Because we are reducing 30% using the PCE or the super plasticizer. So 222 into 0.7 is become 141 kg. So our water content is become 141 kgs. Otherwise, if we have to use 200 kgs of water, the mix will not be the homogeneous, or there's a bleeding can be generated. So next part, we have already find out the selection of water content. We have already find out water content, that is 1.144 kg per cubic meter after adding doses of PCE or the super plasticizer at the rate of 0.5, which is reducing the water content and 30%. So from 202 kgs it's become 141 kgs. So we have already find out the water content, and we have already find out the water cement ratio. So what will be the water cement ratio? Is 0.29, and water content is 141 kg. So what will be the cement content? That becomes the 486 kgs. But in 480 kgs, 86 kgs is not satisfying our criteria. What the criteria? That is maximum cement content is 450 kgs. Can you remember from the clause? Now, and minimum is 320 kgs. It's not satisfying, hence it is not okay. So what we need to do the necessary adjustment. How? We can use the fly ash silica films, then we can find out the right proportion. So code in the given in the IS 10262 and clause 5.4, it has given the permission that whenever we are using fly ash and other cementitious material into the mix, you can increase the water cement percentage in 10%. So from table 9 on IS 10262 is given the guidelines also, what percentage of fly ash we can use. Here it is the guideline. See, fly ash you can use 15 to 30%, GGBS 25 to 50, metakaolin 5 to 10, and silica fume is 5 to 10. It's in table 9 of IS 10262 has given the guidelines. So we cannot increase the fly ash content, GGBS content, silica fume content as per our own requirement. Now for clause 5.4, we are increasing 10% of the cement in the mix. So 486 is become 535 kgs. Now the corrected water cement ratio what will be 144 divided by 535, because we increase the water cement content, it become 0.264. Again, it is valid because our maximum water content, water cement ratio is 0.45. Now fly ash we are considering in 15%. So what is that? 535 into 0.15 is become 80.25 kgs, and silica fumes 5% is become 26.75 kgs. So what will be the net cement content? 535 minus fly ash, that is 80 kgs, and minus silica fumes at 26.5 kgs. Now it's coming 425 kgs. So what is my criteria? My criteria is 320 kgs minimum and 450 kgs maximum. So it is satisfying both the criteria of the cement content as per the requirement of IS 456. Now we need to do the calculation of admixture. What will be the admixture calculation? Whatever the dose we have considered, it is 0.5% of total cement, that is 535. It's become 0.5% of 535 kgs is become 2.65 kgs. Why you need to know? Because each and every element we need to know in percentage or in the kgs, because we are doing the mixed design and we need to find out in kgs itself. So next part is proportion of coarse and fine aggregate in the volume. So from where we can getting is table 10 of ISO 10262 has given the criteria how much percentage will be the coarse aggregate and fine aggregate. No, it is not the percentage of the total volume. It is the percentage of the total coarse aggregate and the fine aggregate. If it is become 1, coarse aggregate plus fine aggregate is become 1, then what will be the percentage of the coarse aggregate? That is given in the clause 5, table 5 of the IS 450, IS 10262. In table 10, the volume of coarse aggregate corresponding to 20 mm size aggregate and fine aggregate grading zone 2 is 0.66 per unit volume of total aggregate. This is valid for water cement ratio 0.3. As our water cement ratio is actually 0.264, so we can take in the ratio 0.667 for the trial mix. It can be varies after the getting the trend. So from table we are getting the percentage of coarse aggregate for the total coarse and fine aggregate is 0.66. So volume of fine aggregate 1 minus 0.666 is equal to 0.333. It is the volume for the total coarse aggregate and the fine aggregate. It is not that the total volume of the mix. It is to be understood very carefully that it is not the total volume of the mix. It is the volume of the total volume of the coarse aggregate and fine aggregate. It is required. So from here we are getting the coarse aggregate percentage is 0.667 and fine aggregate is 0.333. Now we are coming at least the last part, that is the mix calculation. How we will do the mix calculation? See, here it's a percentage wise and we need to do the last part for the mix calculation. So what is my total volume of the concrete? We are considering 1 cubic meter. So entrapped air in the volume, remember that we for the 20 mm aggregate is become 0.5. So for the volume of the air is become 0.005 cubic meter. And what is the cement volume? That is 428 kgs and the specific gravity is 3.15. You can remember in the beginning we have already considered the specific gravity 3.15. So it is required for the calculation of the cement volume or the other volume. So its cement volume is become 0.136 cubic meter. So volume of water 141 kgs divided by 1000 because it's a what specific gravity is 1. Volume of silica fume, that is E, that is 2.65 divided by 2.2 is the specific gravity into 1000, 0.0122 cubic meter. Volume of fly ash F, that is 8.25. Sorry, volume fly ash volume is here it is 80.25. So volume 8 here it should be 80.25, 80.25.2.2, that is 0.0365 cubic meter. Volume of admixture 2.65 kgs and specific gravity is 1.08 is coming 0.0025 cubic meter. Now volume of coarse and fine aggregate. See, in the mix what will be there? Coarse aggregate, fine aggregate, silica fumes, fly ash, cement and the water and the admixture. Now if we minus all these element whatever we are now considering, then what will be there? There will be only volume of coarse aggregate and the fine aggregate. So how we can find out? See, here is A minus B. A is total mix, that is 1 minus 0.005. This entrapped air, so it's become the net volume of the mix. And then this is cement, the C plus D, this is cement, so what is C? Cement, water, silica fume, fly ash, cement, admixture. If you are minus this one, 0.6668 cubic meter is the total volume of coarse aggregate and the fine aggregate in the mix. But in this volume, how much percentage of coarse aggregate? It is 0.667. Now we are already find out here from the table 10 of ISO 1062. So mass of coarse aggregate 0.668 into 0.667 is the percentage in 2.745 into 1000, 1 to 2 kgs. And mass of fine aggregate, this 0.60 for this volume into percentage 0.333 into 2.65 into 1000, it's become 589 kgs. Now we have already find out all the mix proportion for the trial. So what is the final mix proportion? That is cement is 428 kgs, fly ash is 80.25 kgs, silica fume is 26.75 kgs, water is 141 kgs, coarse aggregate in at SSD condition 1220 kgs, fine aggregate as SSD condition 589 kgs, admixture 2.674 kgs, and free water cement ratio is 0.264. Now we need to do the trial mix, and after getting the trial mix result, if it is required any adjustment, we need to do the adjustment, and we need to calculate the final mix design properties. And these are all about the high strength concrete or the M70 concrete mix design. I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you'll get immediate notification. So without wasting time, I'm waiting for your valuable comment, so that from your valuable comment, everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.